Life cycle of a session object in Jakarta Enterprise Beans or EJB. Here you can see basic EJB component relationships. There are 4 major components that you must create to develop a complete EJB. The home interface, the remote interface, the implementation of the remote interface, the actual bean class, a deployment descriptor for each EJB. Home interface is an interface to an object that the container itself implements the home object. The home interface has create methods that specify how a bean is created. The home interface with the home object actually serves as a factory object for EJBs. The remote interface specifies the methods that you implement in the bean. These methods perform a business logic of the bean. Bean must also implement additional service methods that the EJB container calls at various times in the lifecycle of a bean. Client application itself does not access the bean directly. Rather, the container generates a server-side object known as the EJB object that serves as a server-side proxy for the bean. The EJB objects receive the message from the client, and thus the container can interpose its own processing before the messages are sent to the bean implementations. Why is this level of indirection necessary? Remember that the container provides services transparently for the bean. For example, if you deploy a bean with the transaction attributes that declares a bean that the bean must run its own transaction context, then the container can start up the transaction before the message is passed to the bean and can do a commit or rollback as required before return messages or data is sent back to the client. Here this illustrates the interaction among these components here. The bean implementation contains Java code that implements the remote interface and the required container methods. The deployment descriptor is an object that specifies attribute of a bean. For example, the deployment descriptor declares the transactional properties of a bean. At the deployment time, the EJB deployer, together with the application deployer, can decide whether the container should manage transaction support or have the client to do it. The basic concepts. Before going into details about implementing EJBs, some basic concepts must be clarified. First of all, recall that a bean runs in the container. A container which is part of the EJB server provide a number of services to the bean. This includes transaction services, synchronization services, and security. To provide these services, bean container must be able to intercept calls to bean methods. For example, a client application calls a bean method that has a transaction attribute that requires the bean to create a new transaction context. The bean container must be able to interpose code to start a new transaction before the method call and to commit the transaction if possible when the method completes and before any values are returned to the client. For this reason and others, the client application does not call the remote bean methods directly. Instead, the client invokes the bean method through a two-step process mediated by ORB and by the container. First, the client actually calls a local proxy stub for the remote method. The stub marshals any parameter data and then calls a remote skeleton on the server. The skeleton marshals the data and upcalls the bean container. This step is required because the remote nature of the call. The note that this step is completely transparent both to the client, application developer, as well as the to the bean developer. It is a detail that you do not need to know about to write your application code either on the client or the server. Nevertheless, it is useful to know what is going on, especially when it comes to understanding what happened during a bean deployment. In the second step, the bean container gets the skeleton up call, then interposes whatever services are required by the context. This includes authentication of the client on the first method call, performing transaction management, and calling synchronization method in the bean itself, identity checks and switch. The container then delegates the method call to the bean. The bean method executes. When it returns, the thread of control returns to the bean container, which interposes whatever services are required by the context. For example, if the method is running in a transaction context, a bean container performs the commit operation if possible. Depending on the transaction attributes in the bean descriptor, then the bean container calls the skeleton, which marshals return data and returns to the client stub. These steps are completely invisible to the client side and server side application developers. One of the main advantages of the EJB development model is that it hides the complexity of transaction and identity management from developers. Here you can see the xbean x equal home dot create method create. This is calling. This is connected to home through create method, and home is connected to bean through EJB create method. Bean set access create method, and set xxx 42 higher and r3 equal get xxx method is interact with bean methods here through methods. These codes are inside the client, and so home and bean, and here, for example, Oracle API are inside the server. Now, this is the end of my presentation. Thank you very much for watching it.